Cool. So I'm a freelance creative director and creative technologist. My work is quite varied, as you can see here. But the goal is always to create immersive experiences. Sometimes I work on physical interactive installations. Sometimes I create games. I've collaborated a lot with Nike, for example. Sometimes I do a website. I collaborated a lot with Google Arts and Culture, and we're going to cover this a little bit tonight. Some work that you do not see here, it's speculative work about the future of how AI is going to change the future of brands and their products and spaces, and it's all NDA locked, so unfortunately it doesn't make it online ever. But sometimes it's a bit more straightforward in terms of art installation aimed at, kind of video or image driven. So it's all really fun project, but we are not going to talk about this today. We're going to do something a bit different. I grew up by the sea in a small region in the middle of Italy, and I always found the sea to be very fascinating. The more I swam in it, the more I discovered very strange creatures. And I believe that the ocean is mysterious because, as we see in this photo, with this mirror-like surface, we can't really see what's happening below. It's quite imperceptible from land. And also, it's quite hostile as an environment for us because we can't breathe because of the lack for water, the lack of air, and we can't really stand the pressure. So it's really quite alien almost. So over time, I spent quite a lot of time underwater. And the more I swam, the more I encounter really fascinating, amazing, bonkers, incredible creatures, but also environments. And so tonight, we're gonna go away from the desk for a moment, and we're gonna go into the sea for a creative underwater journey. So every start our dive, the first thing that we find is Posidonia. Posidonia that we see here is a seagrass that I photographed in Corsica, and it's quite special because it has some floating fruits that are also called the olives of the sea. And so this ribbon-like seagrass, they really create vast meadows that host, they provide shelter for a lot of marine life, but also absorb a lot of carbon dioxide and produce oxygen. In fact, they absorb 15 times more CO2 than the same sized Amazon forest, let's say. And a fun fact of this Posidonia is that underwater, it really kind of undulates and it has these very soft patterns moving with the current. And it really kind of gives you a sort of a feeling of euphoria, almost making you feel a bit drunk when you look at it. It's pretty special. But chilling on this Posidonia, we can find this little guy that is called a scorpionfish. So a scorpionfish can really blend almost perfectly with its environment thanks to this pattern that they have on the skin and this skin formation, like almost this little beard that they have. So yeah, they can almost disappear and be really good at hunting. Another animal that is amazing in terms of patterns, and you might have to squint to see it, it's a pygmy seahorse. It's what you see in the center of this image. It's less than 2 centimeters long. It's the smallest seahorse species on the planet. And they really become, the way they look, it really becomes the coral they live on. I really hope you can see this, the little black eye in the middle. But as we continue the journey underwater, we really find the king of all patterns. This one is a giant cuttlefish that I encountered in the water of Raja Ampat at the very edge of Indonesia. And it's incredibly special because it's absolutely amazing at camouflaging. It has something called chromatophores on its skin, which really acts like the pixel of your screen, basically. Each of these chromatophore can replicate, for example, the tree branch that's in the back of the image. But this is not the only thing that they're really amazing at doing. If you see the video on the top right, they create these amazing patterns almost of light, like almost washing light over their body, and they assume this weird posture. And what they're doing here, it's absolutely crazy. They're hypnotizing a crab. Being soft-bodied, crabs with their flyer, they can be quite dangerous. And so evolution decided that hypnosis was the way to go for them. And finally, we get to the species that's most special to me, my favorite, the jelly. So this one is a ctenophore, also called comb jelly. And over the 670 million years of evolution, they learned to adapt to become transparent. Imagine you have to hide in the middle of the sea in the blue, where there's no reef, no corals, nothing, and you just have to not be seen by the predators. And so through evolution, they became transparent. They're quite hard to find unless you go at night a bit deeper, where they also start to shine some light on their body. We can see there's some red and green dots on their body to kind of attract prey and soulmates. And this white dot at the center of the image is a Medusa, is a jellyfish that became a Medusa just a second ago. So jellyfish have a very unique life cycle. They start as polyps, which is something that lives attached to a hard surface, is really anchored. And then at some point in their life cycle, they literally take flight, start swimming, and become a jellyfish, a Medusa, which is what we call a jellyfish. And in the Mediterranean, there is a secret location where there is a type of jellyfish that is called immortal jellyfish, because it can literally live forever. In fact, if it's endangered, it can revert back to its polyp stage, revert time, and be reborn as a jellyfish after. Really, time doesn't affect them. But jellyfish have a lot of other impressive abilities. The box jellyfish, for example, is the most venomous in the world. There's one that's called the Eurocandis that is super small. You don't even feel it stings you, but then you don't really have many chances of survival. But there's a jellyfish that, for example, won a Nobel Prize for their fluorescence, and they've inspired all sorts of fields from genetics to robotics and so on. They really come in all sorts of forms, colors, sizes. And for me, I really think they're absolutely elegant and fascinating animal that have the most beautiful patterns. So you heard me saying this word patterns a few times, but it's not something just that touches the body of the jellies, but it's also something that is present in their environment. So we have two maps here. The one on the left is the one of hypoxia, which is represents areas in the Mediterranean that have low or no oxygen in the water, dispersed in the water. Whereas on the right, we have the one of jellyfish blooms that have been spotted and counted over time in the Mediterranean. But as we overimpose them, we can definitely see that there's something going on. There's a correlation. And in fact, over the years, I've seen jellyfish becoming more and more frequent. And I started to wonder if perhaps they could offer a visual clue to the changes that are happening in the seas. And in fact, could jellyfish blooms be nature's very own data visualization and perhaps be revealing hidden patterns in both the ocean health and the ecosystem balance? So this is how the project Medusa came about. Medusa is an interactive web experience that I created in collaboration with Google Arts and Culture. And it really tells the story of the Mediterranean through the lens of the jellyfish. So it's really about understanding what clues jellyfish populations can tell us about the changing climate of the Mediterranean, and also making the jellyfish the hero of the experience and not the bad guy like we kind of most likely often think. It's really a storytelling project that uses data from various entities like NOAA and the IUCN, which is the International Union for Conservation of Nature. And so I hope you can hear the audio. So this is a project that uses data to explore different effects: the rising temperature, overfishing, acidic waters, low oxygen, and the invasion of species are having in different hotspots of the Mediterranean. So first is about learning a little briefly about the jellyfish to bring some context, and choosing a topic to dive and explore. In fact, after it's about exploring. So you choose a location and discover more about the local climate problem, how it affects the environment, and the effects on jellyfish. It's a very simple, very direct, interactive experience online. So the research for this project is something that started from curiosity and continued with all the time that I spent underwater doing dives, but culminated with the collaboration with scientist Fabien Lombard from the Sorbonne University, the professor there. So together we unravel basically the fact that jellyfish really react differently to all the changes that are happening in the oceans compared to other fish species. In fact, they are the oldest animal on the planet. They've evolved over 670 million years ago. And through this time, they've really learned how to withstand even the harshest conditions. They're really marvelous animals. And so now we are on the first chapter of this experience, which is that of temperature increase. So these colored dots that you see on the left are representing a bloom. And this is a rough visualization, both of the size of the bloom, but also of the aesthetics of the jellyfish in consideration, which you can see on the top right. And so the choice of this kind of scattered dots was really through an artistic approach to make you feel almost as if you're drifting with the jellies in the water. But then the rest of the data is narrated in the info card. It was supposed to be a very explanatory project. And so in this case, for example, we are in 2017 on the Tunisian coast, and the temperature here is 2.5 degrees warmer. And the jellyfish, which is called Olidias phosphorica, has a bloom of more than 2,000 individuals. So water that become warmer, in general, on average, the Mediterranean is 1.5 degrees warmer, holds less water. And having less water, this affects the metabolism, the reproduction, and the behavior of all different marine species. But jellies, and you're going to hear me saying this quite a lot, they are not really affected by this. They don't care so much. They prefer warmer waters, and in fact, this one can just cling on posidonia during the day and then hunt and swim at night, undisturbed. For the second for the second chapter of the project, we get to the invasive species. In the Mediterranean, there's over 400 invasive species. And so with my team, we really played with the density of the point cloud to really give a sense of the pressure that these animals were giving. So there's darker spots, the points of the ocean, which is what you see in the background, are becoming smaller and less present. And in this case, we're in 2015 in Haifa Bay in Israel, and Marivaja stellata of course, is an invasive species. They came from the Suez Canal that, brought a lot of economical advantages, cutting time, but on a environmental level, it was quite controversial. In fact, species that came from the very poor Red Sea into the very rich Mediterranean really found, an untouched ground where they could simply flourish. And so the Marivaja stellata can feed on young local fish and endangering the local fauna. As we continue in the experiment, we are in that of the acidic waters. On average, the Mediterranean waters are 3% more acidic. And here, once again, we were playing with the oceans, with the appearance of the sea. You probably have seen or done a pH test in your life before, and the result is basically mapped on this little colored scale that goes from blue, green to red and yellow. And so that was the choice for the environment here. So we are in 2014 in the Aeolian Islands in Sicily, in Italy, which is a group of islands that are actually volcanoes in the middle of the sea. And in this area, the waters are, in some areas actually, are 170% more acidic. The volcanoes basically release a lot of CO2, which lowers the level of pH, and you can imagine water becomes more acidic, and therefore shells and harder skeletons have a hard time to form. They really start to dissolve. And of course, you can imagine, and this has devastating effects on the whole of the marine food chain. But the jellyfish that we see here, Cotyloryza tuberculata, they have a very complicated name oftentimes, that looks like a cracked egg, literally. Has a specific symbiotic relationship with the zooxanthellae, which is a type of algae almost similar to the ones we find in coral, that basically lives within their skin. It captures the CO2, producing nutrient that dampen the effect of the acidification on the jellyfish. As we get towards the end, we have the chapter of low or no oxygen. Remember the map we saw at the very beginning. And in the Mediterranean, there's 59 areas of low or no oxygen, which is a huge number for such a small sea. It's 2017 and we're on the Greek coast, and here there's 2% less oxygen in the sea. I think during the pandemic, we all started to appreciate the importance of small numbers and the effect they could have. And Aurelia Aurita, that we see here, has a bloom of more than 1,200 individuals. And as we mentioned at the beginning of this talk, because of the water warming up, basically the oxygen holds less, the water holds less oxygen, but also due to pollution, etc., the amount of oxygen diluted in the water starts to fall. And it's predicted that in 2100 it will be even less, almost 4% less. But Aurelia Aurita, of course, doesn't really care so much. Not only doesn't care about the lack of oxygen, but also the combination of lack of oxygen, acidification, and higher temperatures. A fun fact about this jellyfish is that it's actually been to space. Scientists wanted to study how gravity affects their growth. Underwater gravity has a different pull, and so they send them to space at different stages in their life to see what would happen. And when they came back, they saw that they were actually a bit deformed, so the gravity really does have an effect. And finally, we get to the overfishing. So the Mediterranean Sea used to be called the cradle of life, but now it's the most overfished sea in the world. And in fact, once again, we wanted to play with the sea, and really we wanted to create a sense of drama, having these particles almost disappear into nothingness. So it's 2015, we're on the Greek coast, and the stock of tuna has decreased by 90%. So Drymonema used to be a very rare jellyfish, but now is left unchecked and can bloom. So what eats jellies? It's of course animals like tuna or turtles or etc. But in general, there's 62% of fish stock depleted. So we're basically taking away all those animals that will keep them in check, keep the numbers of the jelly in check, and so they just go from rare to blooming. So this project has really taught me about the beauty and the fragility of the sea, and especially the collaboration with Fabien Lombard was really interesting, because I thought, and as we've seen also, that jellyfish are absolutely incredible, super powered animals. But if we continue at the pace of change that we're inflicting to the oceans, also them will eventually perish. And so it's really kind of taught me that hidden patterns can be easily spotted if someone paid attention. And that nature has its own very clever ways of doing things. And after this learning and understanding, and realizing that we only know 5% of the ocean, I want to show you my last experiment that in fact rotates all about the fact that we know a lot more of the stars and the space than the blue part of our blue planet. And so I started to wonder what undiscovered patterns might emerge from the ocean's depths. So what species, what ecosystem and systems are hidden below this mirror like we saw at the beginning. And so based on the photos that I've collected during my dives around the world, I've started a collaboration with a machine learning model to basically try to imagine this unknown aquatic life and really try to wonder if there is a machine that could help us discover new species, since oceanic exploration is so incredibly difficult. There's more than 2,000 species discovered every year. There's really so much we don't know. And so therefore, could technology help us unravel this unknown? And so during my days, I've been making new friends. But are they real? Did evolution get in the way of our encounter? Or are they really out there? Imaginary tales of what could be? Or just a play of colors? What is and what could be? So thank you very much for coming with me in this a bit quirky underwater journey, and I hope this gives you the interest of going on an underwater adventure.